What if I told you that right now, across engineering teams at some of the most sophisticated technology companies in the world, there is a mass hallucination happening? Not the AI hallucinating, the humans. Here is the situation. A controlled study, rigorous, randomized, carefully designed, measured what actually happens when experienced professional developers use the most advanced AI coding tools available. Not junior developers learning on the job, experienced engineers, the kind of people who should be getting the most out of these tools. The result? They were 19% slower with AI than without it. 19% slower. Now here is the hallucination part. Before the study, those same developers predicted they would be 24% faster. And after the study, after working through real tasks, after the data had been quietly collected, they reported that they felt 20% faster. A gap of 39 percentage points between what they believed and what was measurably true. They were not lying. They genuinely believed it. The AI felt productive. It felt powerful. It felt like acceleration. And the whole time, invisible to them, it was doing the opposite. How does that happen? And more importantly, what does it tell us about how we should actually be working with AI? That is what we are going to figure out today. Welcome to Mindcast. I'm Will. Every episode, I take one idea that is reshaping how the world works. An idea hiding inside a research report, a technical paper, a quiet revolution in an industry. And I try to make it genuinely useful for you. Today's source material is a proprietary research report I've had the chance to work through. It is a deep technical analysis of what is going wrong with AI-assisted software development and what the emerging discipline that fixes it actually looks like. The full report is not publicly available, but the insights it contains are exactly the kind that should be in wider circulation. So here we go. By the end of this episode, here is what you will have. A clear understanding of why the dominant approach to AI-assisted work right now is quietly sabotaging the teams that use it. A concrete picture of the structured alternative that the best practitioners are moving toward. And 3 habits you can start applying today regardless of whether you have ever written a line of code in your life. Because here's the thing I want to flag early. This is not really a software story. It is a thinking story. It is a story about how human minds and artificial intelligence should divide labor on complex problems, and the lessons apply everywhere. Let us start with the data. Key Insight 1. The AI productivity paradox, and why the numbers are more alarming than they first appear. The study I opened with comes from an organization called METR. It is the controlled trial, small group, rigorous methodology, real-world code bases, experienced developers. And the headline finding is the 19% slowdown I described. But METR is not alone in what it found. In July 2025, Pharos AI published what they called the Productivity Paradox Report. This one operated at a completely different scale. They analyzed actual system telemetry from over 10,000 developers working across 1,255 teams. This is not self-reported data. This is logged behavior, the digital record of what developers actually did hour by hour across months of work. And the Pharos data tells a story with a genuinely seductive opening chapter. AI adoption increased individual task completion by 21%. The volume of code submitted for review, engineers call these pull requests, went up by 98%, nearly doubled. If you walked into a boardroom with those 2 numbers, you would be celebrated. But then, Chapter 2 arrives, and Chapter 2 says, pull request review times inflated by 91%. Think about what that means structurally. The AI doubled the rate at which code was produced and submitted, and the time required to check that code also nearly doubled. So the system, the team, the pipeline, the entire delivery machine did not get faster. In many cases, it got slower,
because the bottleneck was never the writing of code. The bottleneck was always the verification of code.
There is a principle in computer science, Amdahl's law, that makes this inevitable. Jean Amdahl's insight was deceptively simple. The maximum speed-up you can get by improving one part of a system is limited by how much of the total work that part represents. Optimize one component brilliantly, and the other components become the new ceiling. Think of it like a road trip. You swap out your car's engine for one that goes twice as fast. Incredible upgrade. Except your route has 47 traffic lights. The lights do not care how fast your engine is. Your total journey time barely changes. You have optimized the highway and ignored the intersections. That is what AI is doing to software teams. It has supercharged the highway, code generation, while the intersections, the human review steps, the security audits, the quality checks, remain exactly as slow as they were before. And now there's more traffic than ever. The Pharos data shows the downstream human cost of this. Developers in high AI adoption environments are touching 47 more pull requests per day. They are not building more, they're reviewing more, triaging more, managing more, and their code quality is suffering for it. The same data shows a 9% increase in bugs per developer and average pull request sizes ballooning by 154%. More output, lower quality, higher review burden. That is the paradox in 3 words. But why is the quality lower? That is the question that gets to the heart of what is actually going wrong. A separate analysis by CodeRabbit studied 470 open-source pull requests, 320 written with AI assistance, 150 written by humans alone. Same categories of mistakes appeared in both groups. But the AI amplified those mistakes at a scale humans simply do not reach. AI-generated code carries 1.7 times more issues per pull request than human code. Logic errors, places where the program does the wrong thing, not just the wrong way, are 75% more common. Security vulnerabilities appear at up to 2.74 times the rate. And performance regressions, where code silently makes your application slower, are 8 times more frequent. 8 times more frequent performance regressions. The research uses a specific term for what an AI becomes when it operates without a structured framework guiding it. They call it an entropy accelerator. And that phrase does a lot of work. Entropy, in the physics sense, is the tendency of a system to move toward disorder. An entropy accelerator does not just fail to create order, it actively generates disorder, at scale and at speed. The code it produces is syntactically valid, it runs, it passes the basic checks. But it is built without any internal model of the broader system, the unwritten rules, the accumulated architectural decisions, the implicit constraints that a human engineer would carry in their head. So it solves the local problem while quietly corrupting the global structure. And the working practice that enables this, it is called vibe coding. And understanding why it fails is the key to understanding what the solution has to be. Vibe coding is exactly what it sounds like. You have an idea, you open a chat with an AI, you describe what you want in natural conversational language, the AI produces code, you run it, something does not work, you describe the problem, the AI adjusts. You iterate, guided entirely by feel. In the short term, for small, contained tasks, this can feel remarkably productive. You are building without friction, without the slow, deliberate process of designing architecture. Things appear on screen. The AI keeps saying yes. But here is the structural problem. There is no contract. Nothing defines in any rigorous, machine-readable way what the system is supposed to do, what it must not do, what success looks like, what the boundaries are. Every AI output is a guess informed only by the immediate conversation. And as the conversation grows, as the code base grows, as complexity accumulates, those guesses compound. Errors that seemed minor become load-bearing. Architectural decisions made implicitly in message 12 cause catastrophic consequences in message 50.
Vibe coding works at the scale of a weekend project. At enterprise scale, with real users, real security requirements, real stakes, it is systematically generating the fragile, bug-dense, security-vulnerable code the data describes. The AI is not failing. It is succeeding at exactly what it was asked to do. The problem is that nobody defined precisely and in advance what it should have been asked to do. That insight points directly to the solution, and the solution has a name.
Key Insight 2, Spec-Driven Development, and why an old idea is suddenly the most powerful concept in software. I want to do something that might seem counterintuitive. I want to rehabilitate a methodology the software industry spent 20 years learning to hate. It is called waterfall, or sometimes big design up front. The idea was, before you write a single line of code, you plan everything. You document every requirement. You design every component. You write every specification. You lock it all down. And then, only then, do you build. The software industry rejected this approach around the turn of the millennium, and the rejection was justified. The problem was economics. Writing software in 2000 was expensive. Senior engineers were scarce and costly. Compute resources were costly. If you committed to a rigid plan built on wrong assumptions, and assumptions are always at least partially wrong, you had burned enormous resources on something that needed to be torn down and rebuilt. Agile development emerged as the answer. Build incrementally, ship small pieces, learn from real users, adjust. The idea was, do not plan what you do not know, because the act of building will teach you what the plan should have been. This was correct. For that economic moment, it was the right call. But now something has changed, something the Agile pioneers could not have anticipated. The cost of building has collapsed.
When a reasoning AI can generate hundreds of lines of well-structured code in 30 seconds, the marginal cost of execution approaches zero. And when building costs nothing, the economic argument against upfront planning evaporates entirely. The liability was never the planning. The liability was the cost of acting on a flawed plan. Remove that cost, and planning upfront becomes not just acceptable, it becomes optimal. An entire design cycle, specification, research, architectural review, execution, validation can now be compressed into a single afternoon. That is the insight behind spec-driven development, SDD. It takes the old discipline of upfront design and strips away its historical liability by changing who and what does the building. You still think first, you still specify before you build, but now the building part is done by AI at near zero cost, so the old economic objection simply does not apply. SDD rests on 4 core principles. Let me walk you through them, because each one is doing specific structural work. Principle 1. The spec is the direct input, not documentation that sits in a wiki nobody reads. The AI agent reads the spec and executes against it. The spec is the literal instruction set. Principle 2. When code and spec conflict, the spec wins. Always. You do not try to reverse engineer intent from broken code. You regenerate the code until it matches the spec. Principle 3. Structured review gates. The workflow moves through defined checkpoints. Specify, plan, decompose, implement, with validation at each stage. No jumping from idea to final product. Principle 4. The spec evolves before the code does. When requirements change, the spec changes first. Code is downstream of intent, not the other way around.
Now, let me show you what these principles look like in a specific 4-phase workflow. The workflow uses Google's Gemini AI platform, specifically 2 capabilities: DeepThink, which is a reasoning model built for sustained, multi-layered logical analysis, and Deep Research, which is an autonomous agent that goes out onto the live internet to gather and synthesize real-world information in real time. Phase 1 is where the workflow diverges most dramatically from vibe coding. You do not begin by asking the AI to write code. You begin by asking it to help you think clearly about what you intend to build. The developer gives DeepThink a raw description of their goal, the idea, the constraints, the uncertainties. And DeepThink's job in this phase is not to produce anything buildable. Its job is to interrogate the problem statement, to surface the questions you have not asked, to find the assumptions hiding inside your description, to turn your human, imprecise intent into a precise, optimized query ready for research. This matters enormously. One of the most consistent failure modes in human-AI collaboration is that we ask AI to work with poorly formed problems because we do not know our problem is poorly formed. We know what we want to happen. We often do not know what we need to have defined before the AI can do what we want. DeepThink in Phase 1 closes that gap before it causes damage. Phase 2 hands that precise query to Deep Research, and here is where this workflow has a capability that sets it apart from anything else in the market. Deep Research does not consult static training data. It goes onto the live web, right now, today. It reads current documentation, checks active library versions, examines how engineers are actually solving similar problems in the present tense, and it synthesizes all of that into what the framework calls the blueprint. The blueprint is the heart of the whole methodology. Think of it as the architect's complete set of drawings before a single foundation is poured. Scope boundaries, what is in and what is explicitly out. Technology choices, interface definitions, security requirements, verification criteria. A comprehensive, machine-readable contract for what the system should be. And because it is built from live web research, it is grounded in the actual current state of the world, not what the model learned about a year ago. Phase 3 is where a principle called review beats planning comes into play. And this is backed by fascinating academic research. It turns out that using a single AI model to plan something and then immediately execute that plan is measurably inferior to separating those roles. A dual model approach, one model generates, a separate model reviews, produces a plus 10.4 percentage point improvement on coding benchmarks. Generation and critical review are different cognitive jobs. Separating them produces better outcomes than combining them. So the blueprint goes back to DeepThink, but now in a dedicated review role. DeepThink reads it as a critic, not a creator. It looks for logical contradictions, circular dependencies, architectural decisions that will create problems downstream, places where the specification is ambiguous or internally inconsistent. It refines and sharpens until the blueprint is ratified, until it is a document that can be trusted. Phase 4. Only now does any building begin. DeepThink takes the ratified blueprint and executes the MVP. Every design decision has already been made. Every edge case has been considered. Every constraint is explicit. The AI is not deciding what to build. It is doing the focused, deterministic work of building something already fully defined. That last point is more important than it might sound, and it connects to Key Insight 3.
Key Insight 3. Context rot, the silent killer of AI productivity and why the blueprint is the cure. I want to introduce you to a concept that almost nobody in mainstream discussions of AI mentions, and yet it is responsible for a significant portion of the failures that drive the productivity paradox. It is called context rot. Every AI model you interact with has a context window. Think of it as a chalkboard. The AI can only see and work with what is written on that chalkboard right now. Everything in your current session, every message, every response, every instruction, every pivot, every corrected mistake gets written on that chalkboard. Here is the problem. The chalkboard has a size limit, and unlike a real chalkboard, nothing ever gets erased. Everything accumulates.
The early messages where you were still figuring out what you wanted, the ideas you explored and abandoned, the instructions you gave and then superseded with different instructions, the hallucinated suggestions the AI made that you dismissed but that are still sitting on the chalkboard. All of it is still there. As the chalkboard fills, the AI has to read all of it simultaneously. And as any attention mechanism is asked to track more and more competing information, its ability to weight the important things correctly degrades. It starts losing constraints you set early on. It starts building on ideas you explicitly rejected. It starts producing work that is locally responsive to the most recent message, but globally inconsistent with the system you intended to build. The longer the session runs, the more the quality quietly erodes. Context rot. And it is almost entirely invisible until suddenly it isn't, until you have a debugging session that traces back to a corrupted assumption from 3 hours ago. The Gemini bimodal workflow sidesteps context rot through what the research calls strategic structural amnesia. And this is one of the most elegant design features of the whole methodology. Because the workflow is divided into completely separate phases, intent formalization, live research, ratification, execution, no single session ever has to carry the cognitive burden of the entire journey. The planning explorations, the research detours, the architectural debates, none of that ever enters the execution context window. What enters the execution context window is the blueprint. Only the blueprint. A clean, validated, internally consistent document. The chalkboard that the execution agent starts with has exactly what it needs on it and nothing else. Imagine briefing a contractor to renovate your kitchen. In one scenario, you spend 3 months having daily conversations with them, changing your mind about the countertops, debating cabinet styles, going back and forth on the appliances. By the time construction starts, the contractor is trying to hold 3 months of contradictory conversations in their head while swinging a hammer. In the other scenario, you spend that same 3 months working with an architect who produces a complete set of drawings. Then you hand the contractor those drawings on day 1 of construction. The contractor does not need to know about the debates. They just need the final, definitive plan. The blueprint is the complete set of drawings. And the research says that working this way, beginning execution from a clean, structured document rather than a polluted, continuous session can cut debug time by up to 93% in multi-agent environments. 93% less debugging time. Let that land.
Now, let me zoom out to the bigger implication, because I promised you at the start that this extends far beyond software. The failure mode we have been analyzing, AI without a structured contract, generating high volumes of locally plausible but globally wrong output, degrading as context accumulates, this is not a software failure mode. It is a collaboration failure mode. It appears whenever human intent and AI execution are not properly separated by a clean, validated artifact. Think about using AI to write a strategic business document. If you work through a single continuous session, changing direction, layering new ideas, contradicting earlier instructions, you will get something that reads well paragraph by paragraph but lacks coherence as a whole. The AI is not failing, the process is failing. Think about using AI for complex research synthesis. If you stuff everything into one sprawling conversation, the AI starts making connections based on polluted context rather than clean signal. Small errors at the beginning compound into structural problems by the end. The fix is always the same architecture. Separate thinking from building, use a clean artifact as the only bridge between phases, and manage context like the finite and precious resource that it is. And this signals the permanent transformation of the expert human's role in any AI-augmented profession. The job is no longer to produce the output. The job is to define what output is worth producing, precisely, rigorously, with explicit constraints, and to give the AI the quality of instruction that makes excellent execution possible. The developer stops being a syntax generator and becomes what the research calls an intent-driven systems architect, and that shift applies across every knowledge profession. Synthesis and takeaways. 3 things, concrete and immediately actionable. The first takeaway is the one that changes everything else. Stop vibing, start speccing. Before you ask any AI to produce anything, code, copy, strategy, analysis, a plan of any kind, write the spec first. Define what you want. Define what you explicitly do not want. Define the constraints. Define what success looks like. Define the edge cases you can already anticipate. It does not have to be long, it does not have to be perfectly formatted, but it has to exist and it has to be written down before you start. Because the spec is your contract with the AI and with yourself. It is what you point to when the output drifts. It is the anchor that keeps a complex, multi-step AI collaboration coherent over time. Without it, you are navigating by sensation. With it, you have coordinates. I have said this to every developer and founder and PM I have worked with who is frustrated by AI. The single highest leverage change you can make is to stop starting with a prompt and start starting with a spec. The quality difference is immediate and dramatic. The second takeaway, treat AI like a team of specialists, not a single universal employee. The research is unambiguous on this. Different cognitive jobs produce better results when assigned to AI capabilities specialized for those jobs. Reasoning and planning go to a reasoning model. Research and validation go to a research agent. Execution goes to an execution model. The principle underneath this is called separation of concerns, one of the most foundational ideas in all of engineering. You do not design a system where one component has to do everything, because that component will do everything worse than a set of specialized components working in their lanes. Apply this to AI. Your planning session and your execution session should not be the same session. Your research phase and your building phase should be separated by a clean artifact. The model that helps you think through your requirements is not the same mode as the model that implements them. Match the tool to the cognitive job and use the handoff between tools as an opportunity to crystallize what was learned into a clean document. The third takeaway, treat your context window as the most precious resource in your AI workflow. This is the discipline almost nobody talks about and almost everybody neglects. Your context window is finite. It degrades as it fills, and you are responsible for its cleanliness. Practically, start a fresh session whenever you move into a genuinely new phase of work. Do not let planning debris accumulate in an execution session. When you need to change direction, when requirements shift, when you discover a better approach, when earlier assumptions turn out to be wrong, stop. Go to the spec, update it, then open a new session with only the updated spec as context. Do not try to course correct inside a polluted session. It does not work. The AI will keep drawing on the bad context no matter how clearly you try to override it. The only reliable fix is a fresh start from a clean, updated document. Context hygiene is not a minor optimization. Based on the research, it is the difference between a debug session that takes 30 minutes and one that takes 2 days.
Before I let you go, let me trace the arc we traveled today, because I think it deserves a moment. We opened with a mass hallucination. Professional developers using the best AI tools available, slowing down by 19%, while believing they were accelerating by 20%. A gap so wide, it tells us something important. The feeling of AI productivity and the reality of AI productivity are not the same thing, and conflating them is costing teams enormously. We found the mechanism. Amdahl's law. The slowest step sets the ceiling. AI has made code generation fast, but code review, code quality, code security, those are still human speed operations. And flooding them with AI-generated output, much of which carries 1.7 times more bugs and 8 times more performance problems, does not help. It buries teams. We discovered the structural fix in an old, discredited idea made new again by changed economics.
When building is nearly free, planning up front stops being a liability and becomes a superpower. Spec-driven development is not a return to rigid waterfall methodology. It is the merger of waterfall's strategic clarity with AI's execution speed, producing a cycle that used to take months and now takes an afternoon. And we understood why context rot is the silent killer, and why strategic structural amnesia, implemented through a ratified blueprint as the sole bridge between planning and execution, eliminates it. Up to 93% less debug time. The entire premise of the bimodal workflow is giving the execution AI a clean chalkboard and a perfect set of drawings, so it can focus entirely on building rather than on figuring out what to build. 3 habits: spec first, team of specialists, clean context per phase. Take those 3 things and apply them this week.
A quick note on sources. The research report this episode is built on is not publicly available. It is a proprietary technical analysis. But I have curated a reading list in the show notes. The academic papers, published research, and practitioner frameworks that back up everything we discussed today. Those links are there for you, and I stand behind all of them. If this episode earned something from you, if it shifted how you see your AI workflow, or gave you a single concrete thing to try differently this week, I have one ask. Share it with one person, a developer you know, a product lead, a founder running a team that uses AI every day and has never interrogated whether they are using it well. The difference between teams that understand the productivity paradox and teams that are still vibing their way into entropy is going to matter enormously over the next few years. You now understand it. Pass that on. Subscribe to Mindcast so you are here for the next one. And if this episode earned a review from you, that is genuinely the most useful thing you can do to help more people find the show. I am Will, this has been Mindcast, and here is the thing I want you to carry out of today. The quality of your output from AI is determined before you open the session, by the clarity of your thinking and the precision of your spec. Do the hard thinking first. Everything else becomes easier. Take good care of yourselves. I will see you next time.